You know very well what is the proof of the Gauss theorem. Here I am just assuming these things. dA vector, it is a small area vector. R is the distance of the point P from the center of the charge, and Q is the charge assumed by us. Okay, and E is the electric field intensity. We are assuming it. First of all, I want to introduce you what is the charge. It is capital Q, and at a particular point P. Now it is not a point charge. It is not a point charge. Not a point charge. Suppose it is not a point charge. Then what will happen? We will choose a particular Gaussian surface like dotted line here. Suppose it is a Gaussian surface. What is it? It is a Gaussian surface chosen by you. Okay. And now it is so large. It is too much large, so that that particular charge is behaving as an point charge. Listen my friend. Gaussian surface can be of any shape or any size. Here I am choosing it is a spherical. It is a spherical, and it is a huge sphere, so that this one charge, which was not a point charge, but now due to that particular Gaussian surface, it becomes a point charge for this one particular point P, where we want to find the intensity. And suppose a particular point P, a simple small area which is infinitesimally small is known as the dA. And you know very well, its area vector must be outward. It will be the dA vector. Okay. And now due to that particular charge at point P, electric field intensity will also be outward or not? Because it is a positive. And if we are just using a particular test charge here, which must be positive, then it will direct it outward. Okay. So now what will be the flux passing through that particular area dA? What should be its value? What should be the flux known as the d phi, which must be passing through the area dA? So now therefore small flux d phi is calculated as the intensity of electric field at that point and dot product of the area vector. You know, it is a formula. And now what should be its value? It becomes E cos theta as well as the dA. Okay. Now you know very well what will be the angle theta for these two conditions. E as well as the dA will be in the same direction or not. So therefore area as well as the electric field will have the theta 0. Both are in the same direction. Therefore it becomes EdA, which is known as the d phi E. Okay. Now what will be the total flux? Then total flux phi can be written as the integration of the d phi, and it will be a cyclic integration, closed integration, because that particular Gaussian surface is a closed surface, not an open surface like a sheet, like my palm. It is a closed surface like a sphere. So we will use that particular sign here, and it becomes, you know very well, what should be the value of it? D phi E is written as the E into dA. And what should be the value of phi? Phi E equals to E and integration of the dA, area of that particular Gaussian surface, because dA was chosen at the Gaussian surface. It must be exist from 0 to 4 pi small r square. Please see here. You know, r was the distance of the point P from the center of the charge, but now that particular r is behaving as a radius of this one Gaussian surface. Therefore it becomes, you know very well, E, and it will be 4 pi r square minus 0. Okay. It becomes, you know very well. What is the E? You know very well here. E is the electric field intensity at the point P. Here. And since for point P, now this one charge is behaving as a point charge, according to the Coulomb, its value becomes 1 upon 4 pi epsilon naught divided by r square. Charge divided by r square. So now it becomes phi E equals to, you know very well, 1 upon 4 pi epsilon naught, and it will be Q over R square multiplied by the 4 pi R square. Now, they will cancel, So what should be the value of flux? You know very well, it becomes 1 upon epsilon naught times of the total charge. Why I am just saying it total charge? Total charge capital Q, Newton meter square per coulomb is the unit of the flux, and I am telling to you why I am just saying it total charge, because inside of the Gaussian surface it is total charge enclosed. Okay, so it is a proof, hence proved it. It is a proof of the Gauss.